So we've talked through two different real-life examples, where we had a constant rate of change shown in a table, talking about bank balances, and then another where we had a varying rate of change, talking about video game scores. And so now we've just got some points to ponder, some things to think about as we really dive into this idea of constant and varying rate of change using tables. So now we're going to kind of switch our thought process. If we know what it looks like in a table, what does the constant rate of change look like on a graph? Well, if it has a constant rate of change, it has a constant of proportionality, it has a constant slope, which means it's a straight line. It's linear. If it has a constant rate of change, rise over run is always going to be the same. Up $15 over 1 week. Up $15 over 1 week. So it's going to be a line if it is a constant rate of change. What does a proportional relationship look like on the graph? Well, a proportional relationship is a line that goes through the origin. So if something is directly proportional or shows a proportional relationship, it will be a straight line that goes through the origin. What does a varying rate of change look like on a graph? Well, it is nonlinear. So anything that's not a straight line, does not have a constant of proportionality, does not have a constant slope, that's what we call nonlinear. It's not a line. And so some examples of those graphs might be, we talked about when we have functions with x squared, we get something that looks like a parabola. This is a nonlinear function with a varying rate of change. We've also mentioned in class, we've talked about x to the third power and how it makes this little wavy shape. This does not have a constant rate of change. It's changing all the time. And so this is a nonlinear function, and it has a varying rate of change. We can see it's steep, and then it kind of plateaus off, and then it's steep again. Over here, we had a negative slope till we got to the middle of the parabola, and then we had a positive slope. So this is varying rate of change. Whenever something on a graph is a nonlinear function, it has a varying rate of change. So can a proportional relationship have a varying rate of change? Why or why not? I want you to try and answer that for yourself. Can a proportional relationship, a line through the origin, have a varying rate of change and be nonlinear? No, it can't. Why or why not? What do you think? Hopefully you're saying something about proportional relationships have a constant of proportionality. Which means slope which is y over x is always the same. So here's another good question that I already touched on briefly in the first video. Can a graph that shows a constant rate of change be not proportional? We know that if it's a constant rate of change, it's linear. But we also know that there are linear functions that are not proportional. Because if they don't go through, even if they're a line, if they don't go through the origin, then they're not proportional. So can we have a graph that shows constant rate of change and that's not proportional? Sure we can. A straight line that doesn't pass through the origin has a constant rate of change, but is not proportional, just like the very first example that we did in our notes today about Fiona. Fiona, her bank account had a constant rate of change. It went up $15 each week, but at week 0, she put in $70 to start, so it didn't go through the origin. So, yes, it can be a straight line. That doesn't pass through the origin. So today we really touched on constant and varying rate of change. Constant rates of change have a consistent slope, a consistent change. Varying rates of change are different, and on a graph they're going to look nonlinear. So in our next foldable, we're going to really focus on not just looking at constant and varying rate of change using tables, but we're also going to look at them on a graph. And we're going to come back and review that idea of proportional relationship when we do that as well.